Code software. Dead air. Oh no. I don't want to get into solid and dry, and only because I'll screw them up. I'll say the wrong things, and I know there are smarter people out there who can, whip them off. Welcome to episode 2 of the To Code Software podcast. I'm Tim Purdom.
And I'm Tim J.
And today we're going to dig a little bit into some of our favorite things about how to code, from architecture to nitty-gritty details and preferences, lots of different approaches. And we haven't even really decided where we're going to start because we have different approaches to this.
It's more fun that way.
Yeah. So, Tim, why don't you go ahead and give us your big overview, couple of sentences or paragraphs about what you love about code and what you prefer about how to write code.
Oh man, love about coding. I like to solve puzzles. That's been me since forever. I like to solve puzzles. I like to play with Legos. I like to build my own things. And so that's really what I like about code. That's kind of the start and the stop of it.
Right.
Oddly enough, when I started my former, I started working with my former business partner. That was actually one of the questions that he asked me because, he was a lot more business minded. And his question was what's going to keep me motivated to keep working? I lived in Japan, huge time zone difference. At any point, I could have just been nah, I'm done with this and just wandered away. And he would have been able to do nothing about it. And so he asked me that question, kind of where is that motivation when it comes to coding? Because, and he told me later, if my answer had been a paycheck, that would have been fine with him, as long as he knew, what's my thing? And, I'm not saying money isn't a motivator. Anybody who says otherwise is probably lying. But I love to solve problems. I love to be here's a challenge, solve it. Find an answer to this. And yeah.
So how do you go about that? How do you sit down and organize yourself when you're coding?
It's two parts. One, I'm really terrible about wanting to get started coding right away because I don't actually enjoy the process of mapping something out and thinking it through. I like to get my hands dirty. I like to be coding and all of that. So if it's a small enough scope in a project where I'm expecting it to be, oh man, I'm going to have to write 3 classes to do this sort of thing, or this is, a day project, sometimes I'll just start coding to see where the coding takes me, because I can write 100 lines of code and then immediately be I'm already starting to see some problems. I need to think about it this way. And I can iterate quicker that way sometimes than just sitting and trying to conceptualize my way through it. But for bigger projects, I've learned my lesson with trying to start coding too quickly. And one of my big rewrites, I had almost a year, I think it was 10 months into a rewrite before I discovered it wasn't going to work. And that was when I was trying to use NHibernate. I was using Entity Framework, swapped to NHibernate thinking it would be quicker. And I had done so much with NHibernate. And then all of a sudden, one day I was I've wasted all of my time with this. This is never going to do what I want it to do. Right. And then that was kind of my, okay, I need to start planning this out a lot better. And
I probably approach it the same way for myself. I don't spend a lot of time drawing diagrams or mapping things out. I would much rather start coding. But I find that as I've got more experience, what I do is I stop myself faster from that. I refactor earlier in the process. You know what I mean? So
absolutely.
I'm writing a class and, it used to be, I think we even mentioned last week about, our early projects where everything was in one file and 2,000 line classes. And, as soon as I start feeling that itch of this is too complicated, then I start refactoring and pulling things out. I've been doing some side projects. I'm actually teaching a class for mostly kids, just friends and stuff, and just beginning C# development with console applications. In fact, we're creating a chat bot that all it does is, console read line, console write line, and then they have to handle the inputs and do something with them to respond. So it's a really neat, simple project to get kids started with developing and with writing in real languages, because so many of the other kid-friendly things are like Scratch or whatever, which are the concepts are all there, but it's all, graphic and drag and drop and all that.
Yeah. My wife works at the local community center here, and she teaches teenagers, like 12 to 18. And she did that. It was actually one of my recommendations. There's like a STEM class that she does once a week. And one of them is just HTML, because none of the kids had any experience with that. You could just open up Notepad, do a simple, head, body, HTML, and then you could just refresh it in real time and see what it was there. And she did that, and the kids were blown away, excited about that. And she ended up doing a really simple Python one, and the kids also loved that a lot. And I was really like, yeah, get them on a slightly more realistic language at first.
Yeah. No, yeah, that it's really good, and HTML is a great place to start. Although then we could have the conversation about whether it's really a programming language or just a templating language.
If it's Turing complete, that's my criteria. If it's Turing complete, it's a programming language.
Is HTML Turing complete?
I do not believe so. I don't
so.
think CSS is, but there are a shocking amount of things that are. Like I saw somebody had gotten PowerPoint. Somebody had built PowerPoint to be a Turing complete thing. And I was like, okay, somebody's got way too much time on their hands.
So the reason I brought up the class is, so I've been just playing with small projects, things that I could show the class that they could understand, right? And like a chat bot. And another one, and the direction I'm going to try to take them is creating a text adventure, kind of like the old, was it Zork? Is that what it's called?
Yes. You will be, it is dark and you are likely to be eaten by a grue.
Right. And your choices are basically, you can go a direction, you can look at an item, pick it up, you can try to, do something with an item, and the computer has to handle all of those different text inputs.
Yeah. There's actually a couple of engines that exist for that. I've looked into them. Like they pre-exist, and you can kind of code them in their own way, and they're all designed to handle that style of adventure.
Cool. But I want to do I want to build the engine. So I guess that's what that was my point, is in that case, I'll find myself writing out a lot of POCOs, a lot of data objects, and say like, okay, here's the player object, and here's the room object, and here's the item object. And okay, I know that they need to be able to do different things and interact. So here's an event class that details, well, you have to be in this room with this item in order to do this event or do this action. And so I laid all that out, and I realized that after I'd been working on it for hours and hours, that I hadn't hooked up any of the actual game. It didn't do anything, but I had a great architecture, I guess, or at least like a map of the different pieces. But then I realized, like, okay, well, if I'm going to teach it, then probably first I need to do one thing, like move from room to room, And I don't really need all of those classes in order to start.
I feel like that's something that people have been coding for a lot longer tend to do, is that we can kind of skip past a lot of those earlier stages because we're so used to doing them that we can immediately look into that. Your example, I have the exact corresponding one. I play a game called Path of Exile. It's an ARPG, Diablo-like, really love it. And one of the things I wanted to do is I built myself an application to just literally scan one of my tabs and look for certain combinations of items that I could vendor. And I was immediately designing all of these classes for like XY coordinates on the screen and what thing it was scanning and all this other stuff. And I was like 2 weeks into this side project, half an hour a day. And I realized I didn't even have a console application or a starting point.
Right.
I'd written 4 class libraries and not a single way to start it, because that was kind of a foregone conclusion. I'm like, oh yeah, at some point there'll be a console app and you'll literally just run it. It'll fire off a bunch of async code and say, hit enter to quit or something,
Yeah, I don't know if that's a good thing or a bad thing, but it's definitely, I think that is a way of mapping out your project, to write all these classes, and say, well, I know these are all the features that it needs to be able to do, and even if they're just stubs and you just have a method there that has throw not implemented exception,
Hmm.
then at least you can always come back to that and say, okay, I know that I expect this. And when you're writing your application code, your program.main, then you can at least hit that stub, right? And you can say,
Hmm.
all right, I can type in do this and it will compile. It will
Hmm.
fail miserably, but it will compile.
No, throw new not implemented exception is the bane of my existence. I've got code that's actively running out there that probably has a few dozen of those in there, just features I never got around to needing to implement.
I guess I kind of want to look, because you were saying you like to start with that big view of it, and I like to look at the clean code of a single class. And I mentioned last week the clean code book by George Martin, or Bob Martin. George Martin. You know who George Martin is, right?
Yeah.
Game of Thrones.
Yep. I usually hear the RR, but
Right. Bob Martin, or Robert Martin, is a programmer and lead thinker in the Agile movement, and he wrote Clean Code. He also wrote another one I've read called Clean Architecture. And between the two of those, I feel like I got a lot of my foundational ideas of how I want to write code. And so when I look at a class, just from my feeling of things, I think the most important thing as I'm writing, first of all, is how long is this method, or how long is this class? And is it trying to do more than one thing? I mean, that is, okay, it is the single responsibility principle. I can remember that. But that's really important to me very early on as I'm writing. And so, like I said, I'll start refactoring as soon as I see, oh, I'm doing two different things here. Okay, split the method. Oh, this class, like, it really doesn't make sense to be one class. Okay, split the class. And that's where I start getting into more of a design pattern, because I couldn't just fit everything into that one place. Or I could, but it wouldn't be good.
Do you feel at all like, because you've got this really solid background of coming from like a clean code from the very beginning, do you feel that's any sort of disadvantage when you're looking at other people's code? Like, is it more difficult for you to grasp onto, bad or wonky code?
That's a good question. And I do feel like, I mean, there's a huge difference, probably for you too, between writing my own code and updating other people's code, or updating team code.
Yes.
And it's a totally different approach for me. I don't feel like it bothers me too much, in the sense that I can kind of focus my attention on one spot and just fix that spot. If I'm updating a method, then I'm going to ignore all the insanity around that method and and in the rest of the class and in the rest of the library. And I'm just going to fix that method to do what I want. And what I write, I'll try to improve. I'll try to make it cleaner. I'll try to make more sense. But I wait a long time to refactor the whole library. I know at work, I just did refactor a huge library, and we were talking about that. But that's after 2 years of having studied that library. So, I wait a long time before I take those bigger steps, because I want to understand everything. And I think early on, when I started working with other people's code, I would jump to conclusions and assumptions and break things, because I didn't really understand how it worked as well as I thought I did. So I'm a little careful about that.
And see, it's interesting you say that, because it's kind of been one of the more rougher transition times for me, is because all of my code before was mine, and by the time I would recognize flaws in things, a lot of times it was quite a bit into the development. When I finally realized, oops, I designed this thing wrong, there was this kind of realization that it wasn't just one area that needed to be refactored. It was this, my entire CSV parsing library made some assumptions that are costing me problems. And it was always easier for me just to rewrite the entire thing. It was an excuse to swap to a higher version of .NET. Okay, .NET 4.7.2 was out. Oh, now we got .NET Core, which is really cool. And it was always kind of my excuse to start from scratch, knowing everything that it needed to do better than the time before. And that was my way of doing things, is I could recognize a deeply flawed piece of code and then realize that some of the time, even attempting to refactor it in place was a bigger waste of time than just doing the entire thing from scratch. And then when I came to work for the same place we work, it was just that sort of like, this is a deeply flawed thing. Can I rewrite it? And the answer was, no, you cannot. And I understand why, especially now that I understand the code base more. Some of the things I was thinking back then would have been incorrect, but it's still a little difficult for me sometimes looking at code where even the idea of refactoring it is just insurmountable. And so you're a brave man for doing what you had done there, because I saw what you had done and it was like, oh wow, that was a project to tackle.
Yeah, but that's what I meant about like really understanding it before you tackle that. Mm-hmm. I think I didn't have the same impetus that you did coming in because you had a lot more experience before coming to this job. And a lot of refactoring experience, like you said, but it was always your own code. You always understood perfectly what it was supposed to do and what you had done wrong the first time. Mm-hmm. And when you look at somebody else's code, you can say, well, they did this wrong, and this wrong. But, what percentage of that is just our own preference and or the change over time of what is considered good coding standards? Mm-hmm. Because, we are working with a code base that goes back 20 years.
Oh, yes.
And so things have just changed over time. And so that's why I'm saying, I totally get why they don't want us to just up and rewrite everything at once. Mm-hmm. And we do introduce more bugs when we do that. So we have to be careful to really understand all of the edge cases, all of the use cases, why the decisions that were made. And then you can say, okay, but I can do this better.
It's been a wonderful learning opportunity to be faced with that, and I have had quite a few people, yourself included, and this is just a generalized, this is a good thing. If you work with a team, help your team members. Like the number of times I've just asked a question, which is just why have things been done this way? Or explain to me this term or why this exists. And sometimes the answer was, like you had said, this is 12-year-old code. The guy who wrote this isn't even with the company. We don't know anymore. It works. We don't want to break it. Sometimes the answers helped me understand things a bit better. When I came to this place, I knew very little about server communication and web API and all of that. But then being able to ask questions, why was this written this way, helps me to understand a new technology a lot better, because somebody else who already knows that technology decided that this was the right pattern. So I can't just discount that. I need to look at that and be like, this helps me understand the library better.
Right, exactly. So our team that we work on has a style guide, and it's pretty simple. It's pretty it's just the layout. This comes first, this comes second. We put our public things at the top, we put our private things at the bottom.
Here you go. Hear that? It's printed off next to my desk.
So it's not really that complicated, but there are some things that aren't in there. And I remember we had a fun discussion about the length of line, and I just wanted to get into that because, and I'll go ahead and explain my argument first, and then you can tell me why I'm crazy or why you disagree. So I like to use refactoring tools that just cut everything at around 100 characters. And I would be okay with it being higher than 100 characters, but I like to have a breakpoint on the right of my code that says, this is how wide you need to set your monitor or your window to read all the code. Because even if I have an ultra wide monitor, I like to have multiple windows open next to each other, right? Mm-hmm. And I also like the fact that I can pull open my laptop when I'm away from my desk and I can still read the code. Even on a smaller monitor, I can still see all of it. So I was doing that over and over. And then I discovered that, well, nobody else is really doing that. And, some people write 200 characters and some people write 300 characters. We're kind of all over the place. So tell me why I'm crazy or why that's a bad idea.
This is a good conversation topic. Here's my approach to it. One, I have coded on everywhere from about 13-inch laptop screen up to a nice fatty 28-inch 4K monitor. And I absolutely agree that there needs to be some sanity, right? You can't assume that everybody's on some ultra wide high def monitor that can do 1,000 characters wide.
Right.
And my whole thing is that I don't know if there's like an official Microsoft standard line length, but if you look through, Microsoft libraries and everybody else's code, there's some sanity there. Most people don't do, 2,000 character lines. But what I find is I would rather try to kind of format it within itself and not care about how long it is. A method with 12 parameters, which is a bad method, but you can just put each parameter on its own line. And, there's modern formatting tools that will tab it over and make it a nice even thing. But if the name of that parameter and the type together is over 100 characters, I don't care. Because you can get the gist of its type at least by looking at the beginning of it. And if you're really that interested, you can scroll to the right a little bit to see it. I would rather do that than try to do, I have to put the starting parenthesis on the next line and like pull things to the left. And it starts to look inconsistent to me. And so I like to keep things visible. And especially since I often do the split view in Writer or Visual Studio where you've got, code on the left and code on the right. There is a line length there. But for me, it's never like a specific number of characters. It's sort of if it starts getting a little long for the particular code I'm looking at, I'll try to format it a little bit. But if it's one of those things where trying to format it suddenly turns into this weird having to reformat the entire method declaration and all that, I think it's gone too far. Because then looking at it and it doesn't look like all the other methods, I feel that overhead is more than the overhead of having to just scroll to the right a little bit.
Yeah, I mean, I totally get, because if you do it manually, the cutting the line and wrapping it around, then you have to make choices like that. Am I going to break it before the parenthesis? Am I going to break it before a dot? And I also, something that I think feeds into the variety that we have at work is that a lot of our older code base is in Visual Basic instead of C#. And Visual Basic looks much worse with line breaks because it can't handle line breaks the same way, right? You have to add that underscore, in order to get your line breaks. Or you leave your dot or your parentheses on the previous line, which to me looks just bizarre. And when I use the automated tool, it sometimes makes choices that are strange. And, and I think there are ways, there are settings in there that you can set to improve that. And it certainly, I totally get what you're saying also about it not being consistent then, right? So like if I'm doing the same, let's just say I'm configuring something, and so I have to configure 10 different variables with the same method call. And, some of them, the variable name is short, and some of them, the variable name is long. Well, now all of a sudden it looks strange because some of them wrap around and some of them don't. So I get that. And to me, it's not worse than having to scroll to the right. But I do acknowledge that argument. And I think, like I said, mine's currently set at 100 characters. I think if I bumped that up a little bit, I probably would hit less of those edge cases, because I wouldn't be wrapping quite as soon.
It's interesting. Well, you mentioned that you use the styling tools to do all of that, and I don't use those. And for a multitude of reasons. One, because when I first started coding forever ago, I didn't have access to those, and so I didn't really know they existed. But two, the official coding standards of where we work are not at all like my coding standards. And so I haven't spent the time and effort to figure out how to make two completely different styles that are, solution based, so that I don't accidentally reformat work code in my style or my code in work's style. And so because I don't use those styling tools, I guess I just am kind of used to doing the styling in a certain way. And so it takes me a little bit extra time to style it in the way that they want it to be. So that's probably a bit of it too.
Yeah, I mean, I think because I hadn't been programming as long before I started, or hadn't, especially in C#, I kind of adopted our team's coding styles for my own for the most part. And so I can just go with that for my own projects and it doesn't bother me. But the tools, there are ways to do that. Like you can have, like for Rider, you can have a separate .settings file per project or solution. I mean, and there's different layers there, but I'm not going to say I know how to set it up either, because it does get confusing for sure. The other thing I wanted to mention real quick, you mentioned the Microsoft guidelines.
Yes.
And I am going to put a link in the show notes, because they do actually have on their docs.microsoft.com a C# coding conventions page that has like all sorts of, it's got naming conventions, layout conventions, commenting conventions, and most of these things are kind of not controversial, right? So, but it's still a great place to start if you're not familiar with that, or if you're new to C# or something like that. Like the brackets or the curly braces, I wrote in Swift and Java and in JavaScript before I started on C#. And now I'm going to forget which ones are which, but some of those always do the opening brace on the same line as the function or method name, right? And in C#, you always put it on the next line. And so that was like it's kind of just a brain switch thing that you have to, okay, I'm in C# now, so this is where it goes.
Yeah, that always catches me up whenever I'm trying to read Java. It's just close enough that I'm like, oh. No, I love the Microsoft coding guidelines. And because I learned to code reading other people's code, my standards are like 95% the Microsoft standards. Slight variations just due to personal preference, but nothing too groundbreaking. But in my experience looking through other people's code, I would say at least 80% of the code you're just going to stumble across in a NuGet package is going to be about the same. They're going to declare things in about the same order. You'll see some people who will do like partial classes in the same file, just kind of declared with different regions, or some people will split them in multiple files. But like generally speaking, about 80% of what I've seen fits Microsoft coding standards, fits the same layout. Where do you put your fields? Where do you put your properties? That sort of thing. And so the fact that our job is not very close to that, more so the layout of the file, that's been the biggest thing for me, because I'm always consistently starting to scroll in one direction because I'm looking for a field and it's not there. I do like the Microsoft coding standards, and that's pretty much what I would point anyone to, especially if they're like, I'm just starting C#. Learn this, you'll have less of a problem looking at other people's code.
Well, and I wanted to mention to our listeners, hopefully we're getting some listeners out there. I know we put out the first episode just last week and started getting a little bit of interest around it. But if you are a developer and you're listening and you think we're completely off base on this, or you think there's something that we're really missing about it, because I know there's a lot of people out there with more experience than both of us put together. So you can comment on the tocode.software website. You can comment on each episode there, or on the Podbean's website, which is where our podcast is hosted, or even you could leave a comment and a review on the Apple Podcast, because now we're in the Apple Podcast Store, and I believe Stitcher, I just got it on there, and I'm waiting to hear back from Google so that it would be available for Android on Google Play. I think that it's in their review process. So please leave us a message and a review if you can, and that would help us out.
I play competitive Magic for a number of years. I've got a thick skin.
Yeah, you can criticize too, definitely.
Oh yeah.
I know for sure that last week we had some sound quality issues, so we're aware of that, and we tried to. Hopefully this week is better. I've got a different microphone going. So back to design. Let's jump to like bigger architectural design. How do you like to organize different layers of a solution or different layers of a certain project?
Up until I did the really big rewrite in my own personal project, it was kind of just a bunch of classes, right? Everything kind of felt like a class library, a bunch of folders, and everything's just kind of like thrown together there. There wasn't a super great organization. When I did the big rewrite of the software, I really got into domain-driven design, the big DDD. It just seemed to fit my particular use case in that instance. Like everything I was doing research online, it just kept coming up over and over as like, this is kind of how we like to do things. And you can argue that it's a dead pattern. It's a live pattern. It worked perfectly for what we needed to do. And that's kind of the way I organized everything. I have kind of a project for data, and that project was just all sorts of moving data around. And I had kind of just interfaces and implementations, and I don't think it's really the way that it should be done. And I certainly have learned better ways of organizing since then, but it was still kind of an idea of like, okay, if something is going wrong with the CSV parser, I need to look in the data project because I know that everything that's related to moving data and translating data is in there. And it's kind of the way that I thought about it in my head. And as time has gone on, I've gotten better about that. And the way my whole botting system is split up, it's very easy for me to find anything. If somebody's like, I'm having a crash here, I can very quickly narrow it down because in my head, I know exactly what part of the domain that exists in. And so if they're like, yeah, my ads aren't posting correctly, well, I know exactly where ads live, and they're all very encapsulated within there. And I understand, how everything relates that way. And for me, that's kind of how to do it, is just all these individual pieces and how they interrelate. And then you just kind of group them in a way that makes it a lot easier to debug them very quickly.
So how did you learn DDD? Was it a
articles
website,
online? I don't think I ever read a book on it, or if I did, I don't specifically remember which book, but there's a lot of really great articles on there that would go over the process and kind of use hypotheticals where they're like, okay, we're an airport. How would we think about our airport and domain-driven design? And a certain amount of it was just, I learned about domain languages, which I love, and nobody at where we work has ever mentioned that term, but that's a big part of my onboarding process, and that website that you curate is this idea of, when I say this word, what does it actually mean? And it was one of those concepts I'd never really thought about, but then once I stumbled across it, I was like, this is the first step. You have to be able to speak the same language. So if I say, what is an owner versus a chain versus a bot versus a user versus a customer, in my system, every one of those things has a very clearly defined meaning in there. And those words don't mean anything to anybody else necessarily, but to us, they mean something very specific. And once I could speak the language, as it were, which is a big part of our current place of work, once I could speak the language, everything becomes a lot clearer to talk about and to plan, because I'm very object-oriented, and this is a whole larger discussion, but I like object-oriented programming. That is the way I think about programs. And once you can speak a language, language has relation in and of itself. Different terms mean something in relation to one another, like what is a customer to a user and vice versa. And as soon as I understand how to speak the language, I understand the relationships between all the pieces, and that becomes my model.
So is that kind of DDD in a nutshell? Is the idea of the language in the code is matching the language that the company uses for talking about things internally? Or? To
some extent, yes. I don't want to speak too much into it because it's been quite a few years since I read into it, but that was my takeaway from it, was this idea that the design of your program mirrors the design of your domain. And it's like that whole impedance mismatch thing when you're talking about how to store data in SQL, where it doesn't store in the same way in a SQL database as it does in code. And it's that same thing, that domain-driven design is to kind of give you permission to organize the code in maybe a way that's not as good for the code. You're doing it for the sake of the domain. But in that instance, I still found it easier to do everything because I would always approach it from the domain side first and expect the code to be there, rather than start from the code side and try to figure out where it would be.
Sure. No, that makes sense. If you can find a good link to add to the show notes, I'll put it in there.
You've done your own projects, of course. How did you approach your architecture?
Yeah, I pretty much, with my early projects, when I was tinkering with WordPress and things like that, I had no architecture. And, it's just, okay, here's a function. And it wasn't even object oriented. So I didn't really know much at that point. And then when I started doing Swift apps, and like I said, it still wasn't much to it. But when I got to ASP.NET Core, I learned MVC. And that was kind of my first structure that I learned, okay, here I can separate out the code because here's my model and here's my view and here's my controller. And the controller basically just displays the view by feeding it the model, and then handles return requests. It's very asynchronous because it was designed for the web. So it's not like you and I have been working a lot with MVVM now, and that's much more, I would say, real time with the data binding going back and forth.
Yeah.
Whereas a controller, basically, it doesn't remember what it sent out. It only knows what it gets back. Like literally after it displays the view, it's done. And when you get a response, it could be like, I might be saying this wrong for ASP.NET Core, I'm not positive, but like you couldn't trust to just hold on to data on the server for a customer. You basically had to get whatever ID that you sent out to that view, you had to get that ID back so you could look up the data again and update it or do something else with it. So it was very asynchronous response. So I learned that, and as I was learning that, I started reading clean code and clean architecture. And so I realized, okay, I still have all that, but obviously the view in ASP.NET Core MVC is a Razor page. So there's not much in there except, laying out the view. The model was a pretty clean POCO data object with public properties on it. So those were pretty clean, but the controller had like everything in it. It was like calling right out to Entity Framework, and any conversions of data were happening right there in the controller. So then as I started refactoring my website, I built like a service layer. And at first I thought, well, this is kind of silly. Why do I need this extra layer here? It's just more complication. But what I realized was if you have a service layer, first of all, it's easier to find the code because now my service layer was doing all of the business logic and my controller was simply passing it on and doing the communication logic with the website or with the user. And so it was easy to find the code. It was easy to share the code. So I could have multiple points on the website that actually hit the same method in the service layer. I don't think I ever got much beyond those 2 layers, but at our current company, of course, we have many more layers beyond that. And I kind of like
all the way down.
Right, it is. But it does make sense when you see a very clear delineation between the purpose of different parts of the code. Like repository, the idea is it's wrapping, or it's in, what's the word?
Encapsulating.
Thank you. It's encapsulating all of the data access so that it's very easy to swap out and say, like in MVVM, sometimes that's all happening on the client side and you still could have like a web call or something, but it doesn't matter what's happening. You could switch from a monolith Windows application with the database right there to a web application that has to make a call out to a database. And it would be easy to make those swaps because you've got a repository that just takes the same method name and then you can change the implementation. And of course, that gets us into interfaces and all of that, which are super important.
I love interfaces. I love abstract classes. I love static. I wish we had multiple inheritance. I know why we don't. I know that's probably blasphemy. And I really hate interface default methods because they should have just fixed multiple inheritance and not done that because yes. But that's a topic I did want to brush against is
sure.
Use a language because you're using that language. Like if you're going to be coding in C#, don't be afraid of what C# gives you. There's all these people that are like static classes are a code smell, or 3 layers of abstract classes is a code smell. And I don't agree with that. I think that if C# is designed a very specific way where they're going to give you abstract classes, they're going to give you generics, they're going to give you all of this, then use it. Yes, it doesn't have all the features that another language has. Yes, it does kind of force you into certain ways of thinking, but use that. Don't be afraid of it. Don't think because somebody out there said this is bad or whatever to shy away from something. There's nothing wrong with, say, using extension methods. They gave them to us because we got LINQ out of it. And if LINQ exists because extension methods are important and awesome, then why be afraid to use them? It's just one of those.
And a lot of those arguments come down to how you work with a team. The arguments against those things, like the extension methods, it's just a matter of everyone needs to know that they're there and that they're available and where they are. Because, like, for example, we have really old code in VB6 that we work with, and there are common methods in there, global methods that I did not know were not part of the VB6 language.
I got bit by that too.
We're actually written by someone at our company, and that's essentially a global method is kind of the same as an extension method in C# in that sense. So it's just a matter of, like, everyone needs to be on the same page. I don't disagree with you at all that we should be open to using these things. As far as the abstract classes, the one danger I do see with that, and again, it's like, okay, what are we using it for? And does everyone understand? Now, that should be easier to track down and find. Even the extension methods are not hard to find in a modern IDE. You literally hover over it and click on it, and you can find where it's defined. But the abstract classes, because it is a tight coupling, anything you change in the base class affects all of the child classes of that. So it's just that awareness of
I
that
understand where you're coming from.
What I'm saying.
Yeah, I mean, you do have a good point, of course, because the more complicated the code becomes, the harder it is to figure out, if I change this here, what breaks. And as soon as you're talking about tons of protected fields and protected this and internal of that, there's this danger, this genuine danger of, breaking the entire code base with some innocuous change. And certainly a bit of this, again, comes from my background as being the only person touching my code. But I find that you stick to your interfaces, and I love interfaces. I have an entire part of my solution is just interfaces. Like, these are the things that I'm always going to do. But for me, when I'm talking about the implementations behind it, abstract classes make a ton of sense there, because you will find yourself repeating patterns. I use repository pattern in my thing. And part of the way I did my repository pattern is using what they call entities. And so you have this thing called a keyed entity. Does it have integer key? Does it have a GUID key? You know the idea. And so I found myself realizing that, I had an I entity interface and an I keyed of T interface. And I had, some of my entities ended up with 15 interfaces, don't judge. But when I was doing the abstract classes, they would often mirror that, right? Like, I needed an entity abstract class, and then I needed a keyed entity abstract class. And all of these things I'm doing the same code over and over and over again, that when I had these complicated interfaces that almost the whole way up to the chain until the last step or two, it was just a common functionality. And then it made sense to make an abstract class, and then another one that wraps that, and another one that wraps that, because fundamentally they were all interrelated that way. And I still, of course, was hiding everything behind an interface to, hopefully not break compatibility beyond a certain point.
So the other option there is to do the composition thing, which might not work in all scenarios, but the idea there being splitting up the responsibilities of that class and giving all of the classes that are inheriting this interface the same helper classes or different helper classes depending on their implementation. But rather than passing functionality up the abstract inheritance chain, you instead have one class that does that particular thing. Now, in the case of entities, that probably doesn't apply, because you're not really talking about a lot of functionality. You're talking about, like, what fields does it have or what properties does it have. So in that case, I totally agree. Yeah, you end up with
I guess
you end up with a lot of the same things with abstract and
for
interfaces.
me, I get composition over inheritance. Like I've read many articles on it, and I've never ever found a use case, at least in the stuff that I've done. I'm not saying there aren't use cases, because as much as I dislike NoSQL, I will acknowledge that there are excellent use cases for it out there, narrow as they may be. And that's my main thing is just I've never found an instance where inheritance bit me, and I've never found a case where that composition represented some savings of time or effort or, whatever. Most of what Microsoft's code is, like the stuff that I've looked through, they tend to do a lot of inheritance. And granted, some of that is speed related, because generally the patterns for doing inheritance are faster than doing composition. But it's just, again, I haven't seen an instance where I looked at it and I'm like, that's exactly the perfect use case for composition, and now I get it.
Yeah, I'm not sure I know enough to give you an example right off the top of my head, although I am using some composition like that at work that I think we've looked at together. But because there was that one place where I accidentally still called it a base class, even though it wasn't inheriting. It was a helper class, but I called it base instead because I couldn't think of the word at the time. So, I think using them interchangeably is fairly easy, but I agree. I don't know of a great scenario where you say, well, this is obviously better with composition than with inheritance. So yeah, something we probably should look into more, because I'm sure there's a reason. I mean, I do think, it boils down to the concept of the tight coupling and loose coupling. I think that's the underlying reason why one might be better than the other. But as far as describing that and proving that, I couldn't do it.
So we started this whole thing talking about a couple of acronyms, but you also know YAGNI, right?
Yep.
Yeah, okay.
You ain't gonna need it.
Your tight coupling, loose coupling argument, I've actually had that argument a couple of times. And YAGNI is kind of my way of thinking most of the time. Like even, yes, I did have to tear out Entity Framework, and then I had to tear out NHibernate. And so I should have designed things really broad and not tightly coupled there. But other than that one instance, I have never needed to change anything. The CSV parsing library I chose, I'm still using it. The ORM I chose, I'm still using it. I never once needed to abstract away. I use a logging framework called Serolog. I love it to death. I would recommend it very highly. Once I started using Serolog, I never once found the need to change it, ever. And so the idea of like using, Microsoft's iLogger interface, or like abstracting, it always felt like YAGNI, like you're not going to need to do that. Yeah, I'm sure there's instances where people are really thinking about that, but that's why I don't really mind tightly coupled code, because I'm not going to need to change it. Or at the point where I finally decided to get off this ORM, whatever I'm going to use, it's going to be specialized in its own way. And it goes back into the, if you're going to like C#, use it. If you're going to pick a third-party library, embrace it. And so I don't like the idea of these like 5 layers of abstraction away from whatever ORM or even database you're using. I understand if you genuinely think you're going to swap it to do so, but like I'm using NPOCO as my ORM against Postgres as my database. Postgres has some amazing features that are not part of the SQL standard. So if I write everything agnostic to just SQL standard, I lose that. NPOCO has some amazing ORM features. The reason I chose it over like Dapper or NHibernate or whatever else, as soon as I try to abstract those away, I lose that. I lose the reason I chose that. And so I'm not afraid of tightly coupled code. I think in a way you get such better features and better performance just accepting that that's the way it's going to be.
Yeah, I mean, I think again, you are betraying your roots as an independent developer because part of the loose coupling, and abstraction in that sense is to support future developers working with your code. and to make it easier for them to make those switches. I'm not discounting what you're saying at all. I totally agree that if you have like a database abstraction or repository that sets it to the point where you can't use any of the important features, well, then that's a problem. And probably underneath the abstraction, you still need to optimize things for whatever, like for Postgres or for SQL Server or whatever it is. So, yeah, I totally agree with that. But I think it's also just a matter of making it easier for the next person, because honestly, it might not even be the developer. Like, we use SQL Server at work, but that's an expensive product. And there's a lot of cases where financially it might make sense to switch away from SQL Server and switch to something free like Postgres or MySQL or whatever. So you could see that happening just from a business point of view, right? You could just say, like, all of a sudden the business says, well, we're not going to use that anymore.
But that's the exact example when Yagni, you might need it. You could like make that decision now, like realistically. Sure. And there's certainly that thing. And when I thought about it, I knew that I wasn't going to change any of that stuff. And so, I knew that what I had chosen was good. In that aspect, I never was faced with that. But if I had been faced with a situation where I was like, oh yeah, there's a very strong chance that I'm not going to like Postgres and I'm going to swap over to MySQL, then I would have tried to write things a bit more that way. And so in the business use case, what you just said there, I would absolutely do as many abstractions around that as possible.
Yeah, Yagni is very important, but it's always a sliding scale. It's always a matter of trying to anticipate the future and at the same time trying to save yourself time now. Another thing that, since you said Yagni was kind of one of your driving principles as you were developing, for me, it's the DRY principle. Wait, what does DRY stand for? Yeah, don't
repeat yourself.
I think that's it. Yes, don't repeat yourself. I just said it twice now. That means I get itchy whenever I start writing the same code again. And sometimes it's not obvious how to avoid that. Sometimes it is possible for you to combine things together that maybe that's a questionable thing, and maybe it makes it worse somehow. Like, two things use the same, I don't know, they need the same method call, but they're otherwise completely unrelated. They're in different libraries. They're in different parts of the code base or whatever. That's a good place for composition, by the way, because then you can inject whatever shared logic you need from some third place. And so that pushes me all the time when I'm writing. And
I agree with that.
See something where I'm doing it again and again and again. Well, okay, let's talk about a domain model idea that is a good example of that. If you have the vehicle model and you have the car model and you have the truck model and all of these things, of course, they should be either inheriting or, at least have interfaces that match or whatever. But everywhere you use that in business logic, it's really easy to find yourself duplicating it, writing truck logic and then writing car logic and doing it twice. I've seen that a lot where somebody has done that. And that always, I'm like, wait, why don't we just use the abstraction or the interface of vehicle and do it once? And so that is something I find really important, that we find all those spots, because when you don't find those spots, you fix one of the two. And now you have half of your code is fixed and half of your code is still broken.
I absolutely agree. And I've appreciated how much consolidation you've done with the code that I've read of yours. And I'm much the same. And in fact, that does kind of go back to why I'm a really big proponent of like abstract classes, because if you're combining logic together, sometimes a common base class is a really good spot to put that. Static helpers and stuff are also there as well. But I do also agree with DRY, like, it's so easy to do that, to write a method and then to copy paste it because it's really fast to copy paste that code and then later on you change it one place and then not the other, and then you're spending forever trying to track down a bug, and that's why, again, don't be afraid of abstract classes if that's the best spot for that shared code.
Yeah, definitely. So let's go on to our hotspot. Did you have a pick for the week?
Hotspot pick for the week.
Oh, I forgot to warn you. I forgot to remind you.
Yeah, that's okay. That's okay. I'm right, being put on the spot.
I can go first, and then.
No, I got a good one here. Just shout out to JetBrains. I like Rider a lot. I like ReSharper a lot. I use DataGrip, which is their kind of like SQL database thing. It works very well with like every database thing you've ever heard. I've used .peak to decompile things. Their products can be pricey. They have different licensing and all that too, so it depends on the person. I've been a subscriber for a very long time, and I just really like their products. They're not always spot up to date like Visual Studio can be, and there are gotchas here and there. They don't really work with XAML well, etc. But their products are consistently very fast and very consistent among them, and I find myself truly enjoying everything that they do, and they make my development life significantly better.
Well, you have paid me back for not reminding you about the hotspot because you just took mine. But mine was more specifically on Rider, so I'll talk a little bit more about that. So Tim and I both love the JetBrains products, and me specifically on Rider. We both started, of course, with Visual Studio and soon learned about ReSharper, which is an amazing plugin for Visual Studio that does extra analysis as you're going through, and then like code cleanup things, all of what I was talking about earlier in the episode about, it'll rearrange the file in the expected format, and it will do the line breaks for me and all of that. That all comes from the ReSharper engine. And what we discovered is a really big solution can really crawl in Visual Studio nowadays. It can really come to almost a screeching halt depending on how big the solution is. And Rider,
even without ReSharper, like with ReSharper, it'll crash. Without ReSharper,
right.
It'll still, yeah.
Exactly. ReSharper makes it 100 times worse once you get to that point. When you're writing a more normal sized solution, you don't even notice this, and they work beautifully together. So what we moved over to Rider, which is the JetBrains IDE, which is a Java-based IDE that they use for all different languages. I think I'm trying to remember what the other IDE implementations are called, like PHP Storm. Is that one of theirs? I don't know. Anyways, you can look on the JetBrains website. They've got like an implementation for lots of different languages, and the .NET implementation,
WebStorm, and PHP Storm,
Yep. The .NET implementation is called Rider, and basically all they did is they took that cross-platform IDE where you could type your code in, and they made the ReSharper engine be the code analysis for it and be the brains behind it. So it's using the exact same tools that we're used to from ReSharper, but they are now integrated into this other IDE that seems a little bit more lightweight and able to handle large solutions better. It's got some other features I like in it as well, but like Tim said, there are certainly things that could be gotchas if you're coming from Visual Studio.
I have to leave Visual Studio installed because there are some reasons you have to go back, but it's forgivable.
Right. Yeah. And they're doing amazing things. They've got an issue tracker that you can put in requests for things, and they're very responsive on that. Can't recommend it enough. So, maybe JetBrains wants to give us a sponsorship for the podcast after all that. Well, I think that about does it. Did you have anything else you wanted to share this week, Tim?
This week? Nah, got to save up something for next week.
That's right. I think this was a very broad overview of kind of our preferences and the way we like to code. But I think we mentioned a ton of topics there that we could go into more detail on in the future, from domain-driven design and other I didn't even mention, but I've studied some test-driven design and kind of love that. Not that I do it religiously, but I do love the idea of it. And we've talked about lots of different technologies, the different database technologies. We, in very short passing, mentioned dependency injection, and we have different experiences with different tools for that too. So that would be another one that we might want to talk about. But again, if you go to code.software and leave us some notes on our episode 2 page, or leave us a review on Apple Podcasts or Stitcher, or soon to be on Google Play, then we will take those comments and you'll help us develop the future of this podcast. You can reach me at Tim Purdom on Twitter. And TJ, do you have anything working yet on
I'm going to make
media?
a Twitter specifically for this that's a bit more like professional than my personal one. I am working
Sounds
on
good.
it. I will hopefully have it by next time. In fact, I will write it down.
No problem. You can contact me for now, and we'll pass on the messages to Tim J. All right. Well, thanks a lot. Have a good week, Tim.
Yeah, you too.
All right. Talk to you later.